Okay, we're looking at a coordinate geometry question involving straight lines, going through two coordinates here, which I'm given 1, 7 and 5, 1. The first question, A part 1, asked me to find the gradient of the line AB. Now, it can be useful for these to do a quick sketch if you're not given one to start with, so I'll just do a rough sketch of it using two axes here, y and x. Coordinate 1, 7 is point A, or 1, 7 is up there, so that's A, and B is at 5, 1, so 5, 1, B there, and B. And if I just draw a line between those two, I can see straight away that my gradient that I'm looking for is going to be negative. It's sloping downwards from left to right, so I must get a negative answer for this. That'll hopefully stop me making these silly mistakes. I'm then just going to use the quick formula for gradient, which is y2 minus y1 over x2 minus x1. It doesn't matter which one I pick as coordinate 1 or 2, but I'm going to say point A can be coordinate 1, point B can be coordinate 2. So if I fill in the values, just substituting in from here, my second y coordinate is this one, 1. Subtract my first y coordinate, this one, which is 7, over my second x coordinate, 5. Subtract my first x coordinate, which is 1. 1 minus 7 is negative 6. 5 minus 1 is 4, so I've got negative 6 over 4, which is negative 3 over 2, or minus 1.5. That's the gradient. For part 2, I'm going to use that to show that the line has AB has equation 3x plus 2y is 17. Now, if I can find the equation of a line, I'm just going to use y equals mx plus c, because I've already found the gradient, so I can just substitute it straight in from here. M represents the gradient, so it's going to be negative 3 over 2x plus c, which I don't know yet. I'm not given the y-intercept at any point in the question so far. I'm going to need to work it out. So to do that, I can substitute in any xy coordinate into these values here that I know it goes through the line. So I've got 2 points here, A and B. I know it goes through both of those, so I can substitute either one in. I'll select coordinate A and substitute in the y value from here, which is 7. And the x value is just 1. Negative 3 over 2 times 1 is just negative 3 over 2. So that's worked out quite nicely. And then to solve the equation, I can just add the 3 over 2 onto that side to get rid of the negative 3 over 2, which is going to do the 8.5. So c must be 8.5. I can now go back to this equation, where I was just missing the c, and fill in that value that I now know is 8.5. And I've got the equation of the line, but I don't have it in the form the question is asking me for, so I need to sort of do a little bit of algebraic manipulation here. So clearly I'm going to need to get rid of these fractions, so I'm going to multiply by 2 to get rid of that one, multiply that by 2 gets me 2y, multiply that by 2 gets me negative 3x, and multiply 8.5 by 2 gets me 17. All I need to do then is add 3x to get rid of that minus 3x, must be x plus 2y equals 17. Which is the exact answer to the equation, as the question wanted in the first place. Okay, to do the next bit, part B, intersect. Now, as soon as you see that word about two lines intersecting or two curving a line, it's got to be simultaneous equations. So for part B, I know I'm going to be using simultaneous equations. I've been given the equation of the first line, 3x plus 2y equals 17, and here I'm given the equation of the second line, x minus 4y equals 8. To find the intersect point C, I just need to solve those simultaneous equations. Now there's lots of ways to do this. My personal preference would be to double this first equation, because that's going to get me 6x plus 4y equals 34, and then I can just use these two, because I've got a minus 4y and a plus 4y. So I've got sort of equal but negative versions of these coefficients of y here. I can just add the two equations together. That's going to be the y's. So x plus 6x gets me 7x, minus 4y plus 4y is nothing, which is what I wanted. 8 plus 34 is 42. 7x is 42, and fairly obviously by dividing by 7, x must be 6. To find the value of y, I can use any of these three equations. I think this looks the simplest, so I'll use that one and just substitute that value of x back in. So 6 minus 4y is going to equal 8 from here. So just solving that, I'm going to add 4y into both sides because I don't really like it being negative. So 6 equals 8 plus 4y. Subtract the 8 from both sides to get all my constants from the same side. Negative 2 equals 4y, and then just divide through by 4. Negative 2 divided by 4 is negative a half, so y must be negative a half. The question actually asked for me to find the coordinates of c, so I should put my answer in the form of a coordinate. So therefore c is at the coordinate x was 6, y was negative a half. So that's the coordinates I need to use. For part C, find an equation of the line through A which is perpendicular to AB. So if it's perpendicular to AB, that's telling me something about the gradient. The gradient of AB from earlier on I found was negative 3 over 2. If you've got two gradients that are perpendicular, gradients M1 and M2, and you multiply them, you get negative 1. I found earlier that the first gradient was negative 3 over 2, so I had to select a value for the second gradient that will multiply with that to get negative 1. Well, hopefully it's going to be because negative 3 over 2 times 2/3, negative 3 times 2 is 6, 2 times 3 is 6, so it will be negative 6 over 6, which is negative 1, as desired. So my second gradient for the line perpendicular to going to be 2/3. So again, I'm just going to apply y equals m and fill in the gradient, which I just figured out using y is 2/3 x plus c. And then I'm going to use exactly the same technique from A part 2 and substitute in one of these points up here, except this time the line only goes through A, it does not go through point B, so I must use point A to substitute it in. Other than that, it's just exactly the same. So y is 7, x is 1, 2/3 times 1 is just 2/3. So again, I've just got a simple equation to solve by subtracting 2/3. So 7 subtract 2/3 is 6 1/3. That's going to equal c. I can then go back up here and just fill that in from the value of c, which I've now worked out was 6 1/3. And there's my final equation of the line through A, which is perpendicular to AB.